Okay, well, the physics content this week out of Chapter 2 of the Energy textbook focuses on describing motion. That means finding ways to measure, to characterize, to understand how objects move. And in order to do that, we're going to use equations, we're going to use graphs, we're going to use measurements of several different quantities related to the motion of an object. So kinematics is the part of physics that focuses just on describing how objects move without understanding necessarily why they move. There's three different concepts involved in kinematics. Those are displacement, velocity, and acceleration. And we're going to focus this week on in this video on displacement. So what's displacement? Displacement is a change in position. So if an object moves, it has displaced. And you calculate it by taking the final position minus the initial position. So if an object starts at a position of 5 meters, that's the initial position, and it ends at a position of 9 meters, that means its displacement is 9 minus 5. The displacement change is 9 minus 5, which is plus 4 meters. It moved 4 meters. Position is defined in terms of a frame of reference, meaning wherever the 0 point is defines the frame of reference. And displacement is a vector quantity. That means it has a direction and a size. So this plus 4 meters means it's to the right by 4 meters. And the displacement of an object is not the same as the distance it travels. Let's talk about an example of how that happens. So let's think about throwing a ball straight up in the air. And this cute little picture has two dogs throwing a baseball up in the air. Think about what's the displacement of this baseball as it travels from one hand up and then back down if it's caught at the same point from which it was released. So the displacement is, again, writing down that definition equation, is delta x is final position minus the initial position. All right, well, the initial position is right here. That's xi when it leaves the hand of this dog. And then it travels up like that. And as it goes, it slows down because gravity is slowing it down until it comes to a rest for just a moment up at the top. And then it turns around and falls back down, and it gets faster and faster as it goes until it comes back down to the same height that it started at. So there's x final, there's x initial. So if I subtract the initial position from the final position, what do I get? Well, in this particular case, I get 0. Why do I get 0? Because the object ended and started at the same position. So the displacement is 0. But the distance traveled isn't 0. Clearly, it did travel some distance. It went up in the air. Based on the scale in this picture, I would estimate maybe it goes 2 meters up in the air and then 2 meters back down. So that's a total distance traveled of maybe 4 meters, but the displacement is 0. So an important thing to remember here is that distance is not the same thing as displacement, although those two concepts are clearly related to each other. Distance not equal to displacement, and this is an example of how that can be true. So now I want to make a graph of the position of that ball as it travels up in the air. So this graph is showing time starting at time 0 and time going forward. From the moment the ball leaves the hand, it travels up, so this is showing the vertical position, and then comes back down again. So each point on this graph is showing a moment in the flight of that ball. So at time 0, it is in the dog's hand and just about to leave. And then a little bit later, it is higher in the air. And then a little bit later, it's a little higher in the air again. And then a little higher in the air again, a little higher in the air again. This graph is answering the question, at this moment in time, where is the ball? How high is it? So I look at the time, go up to the graph, and I can see what height the ball was at that moment. So you can see it's slowing down because it travels a little bit less distance each moment, and then it comes to a rest for a moment up at the top. So at this moment, halfway through the flight, it's at the high point, and then it starts to fall again, getting faster and faster as it goes, so more distance each moment in time, until it comes back down to the hand again. So you can see that because the starting height and the ending height are the same, the displacement is 0. But the distance traveled, that's the total distance from the start up and back down again, is not 0. So these graphs are showing other possible position versus time graphs, and I want to think about what each one of them means. So at least one of these graphs is impossible. It shows a motion that doesn't make any sense, and I want you to stop for a moment and think about which one you think is the one that's not possible. Okay, so now I'm going to step through each one of them and talk about what they mean. So each graph, again, is showing the time and position. So each point on this line is answering the question, at that moment in time, what position is the object at? And you can see this object is starting at some spot, and it travels up, it comes to a rest for a moment, it turns back around again, and then it turns around again and goes forward. So this makes sense. This is going forward, stopping, turning around, going forward again. That makes sense. I'm going to skip this one, which is sort of a hint. This is the one that is the impossible one. This one, again, answers the question, where is the object at different times? It's there, it's there, it's there, it's there, it's going forward, it's stopping, it's turning around again. That one makes sense too. There's nothing wrong with that. This one, however, so it starts out, it moves forward, it stays in one place for quite a while, and then something really funny happens right here. So if I want to ask what position is the object at that moment in time, I go to the graph and I see it's there and it's there. What does that mean? Or if I look at what's the position at this moment in time, oh, it's there and it's there. This graph seems to suggest that the object is in two different positions, so because the vertical shows position at the same moment in time. So at this moment in time, there's two positions. That doesn't really make sense for a physical object, so that's the one that's impossible. So as you're thinking about displacement and answering questions this week, I want you to think about those distinctions between position and displacement, how much the position changes, and distance traveled. And think about these graphs as ways of describing how an object moves.